In a previous video, we took a look at the Creality Ender 3 KE, and in this video, we're taking a look at the next model up in the Creality Ender 3 lineup, and that is the Ender 3 V3. Now, there are a lot more differences than there are similarities between those two machines, and I'll highlight the differences shortly. This thing, in my opinion, should not really be a part of the Ender 3 lineup because of the differences that we'll get to, but it's just a name, so we'll let it slide. I received this printer pre-release, so I really tried to take my time and put some miles on this machine before releasing this video, and I hope you guys can appreciate that I don't rush through these reviews just to take advantage of the YouTube algorithm on a new and trending machine. There's a lot of material to cover in this video, including some upgrades and a lot of prints, so let's get started.
As per usual, we'll begin with the unboxing, and the Ender 3 V3 comes nicely packaged. The only unusual thing you might find about this package, if you've owned previous Ender 3s or other 3D printers, is that it's very light, unusually lightweight. But regardless, it's packaged in a similar way where you'll find all of the accessories on top, and then underneath of that, you'll find the pre-assembled gantry, and below that, you'll find the printer base. And once we pull all of those objects out of the box, this is what you're looking at. A lot of it is all of the familiar parts, including the power cable, some sample filament, spool holder, one odd little piece here, which we'll get to a little bit later, as well as some tools and accessories. Assembling the Ender 3 V3 is super easy, as most of it is already pre-assembled. The one thing you have to watch out for before you put anything together is take a look on the side of the base. There's a voltage selector switch for the internal power supply, and you're going to need to flip that over to the correct supply voltage in your country, because once you put the gantry on top, like so, you will no longer be able to access that switch. And so as you can see, the pre-assembled gantry slips directly on top of the base, and then you can use the M4x8 button head cap screws to start securing the gantry to the base. There are 2 screws on each side of the printer, and then you'll have to flip the printer carefully onto its side, where you'll find 2 more holes again on both sides for a total of 8 of these M4x8 button head cap screws. Now, I've personally never had any of these screws come loose on any of my printers, but with these new high-speed printers, there is a lot of vibration, so if you have some thread locker, it may be a good idea to add that to the threads. Next up, we've got the screen, and it's got a single connector receptacle at the back, and these 2 tabs here which will lock it into the frame. The connector can only be inserted one way, so you can't install it backwards, but don't try and force it. Once you've got it plugged in, you can insert those 2 tabs into the frame and then push the screen down to lock it in place. Now we can turn the printer around, and there are a few more connections at the back of the printer that we need to make. The first one being on the left-hand side, we've got the first Z stepper motor, and you can see the cable is labeled with a small yellow tag with the letter Z or Z on it, depending on where you are in this world. You may say it differently. And on the other side, you've got the same connector for the second Z stepper motor, and then a small connector here for the Z axis limit switch. All of these connectors are keyed, so if this is your first time putting a printer together, don't worry, you can't put any of these in backwards. Coming into the printer on the left-hand side, there's a long wiring harness that's protected with a braided cable. You'll find a white connector that goes into the side of the filament runout detection sensor. The other cable with the black connector can be routed through the strain relief above the filament runout detection sensor and up and over to the print head, where you can plug it in at the back of the print head. Then you can use the included cable tie to secure this cable down to the print head. Use the side cutters to trim the excess off, and then in your accessory package you'll also find this small plastic cover which snaps into place above that cable. Then we can grab the PTFE reverse Bowden tube, and there are a few retaining clips. You'll need to slip those on top of the tube before we make the connections. One of them goes to the print head, and the other one goes above the filament runout detection sensor, and then the clips will clip onto the wire harness that we just installed on the print head. After that, we can install the spool holder bracket or arm. There are 2 holes on the side, and they will slip over top of the shoulder screws on the right side of the frame. You can press it down and it'll lock into place, and then the spool holder itself just twists inside of that bracket, and it'll face towards the rear of the machine. Now we can get into the setup, and the first thing you want to do is turn your Ender 3 V3 on. you'll be greeted by a welcome screen, and then you'll be taken step by step through the various initial setup parameters, such as language and time zone settings, as well as binding to the Creality Cloud service, which I generally just skip, and you'll also be prompted to connect it to your local Wi-Fi network. Once that's complete, you can start the self-check procedure, and it's going to go through a series of checks such as heating the nozzle, heating the bed, turning on various fans, and finally ending with the input shaping and auto bed leveling tests. If this is your first printer that's capable of input shaping, it's completely normal for the machine to make all sorts of vibrating and humming sounds while it's performing this test. And finally, with the auto bed leveling, you'll notice the print head come down and probe the print bed, essentially creating a matrix of measurement points representing the profile of the print bed surface. After that, we're ready to finally load some filament in. So in the main menu, you can tap on the nozzle icon and you can preheat the nozzle to 220 degrees Celsius if you're loading in some PLA. And we can put that PLA on the spool holder on the side. Then we can grab this interesting looking bracket that's new to the V3. Never seen this on any other Ender 3 model. And it snaps on top of the spool holder, and then you push it down and the spring should sit inside of the spool. I believe the intent of this thing is to prevent the filament from backfeeding and then falling off the spool and then getting tangled up during the process in which the gantry moves up and down. It's an interesting concept, but we'll see how it works in practice. Otherwise, we'll take the free end of our filament and we're going to feed it through the filament runout detection sensor, through the reverse Bowden tube, and eventually it'll come out the other end at the print head. Now you can feed the filament into the extruder, and you're going to want to make sure that your extruder lever arm is in the unlocked position. So the unlocked position is flipped to the right, and you should be able to wiggle the filament in there and get it seated down near the hot end, where if you press down hard enough with a preheated nozzle, you'll be able to purge some filament. Now that we're done with the setup, I do want to just take a moment here and talk a little bit about some of the new features with the Ender 3 V3, because it is a unique printer in terms of the Ender 3 and even just generally the Creality lineup. And so the biggest deviation from all of the Ender 3s of the past is this Core XZ motion system. The Z axis is now belted, so at the back of the printer you'll find two vertical linear rods and the belts, but what you won't find are the traditional lead screws. This should eliminate Z banding and Z wobble artifacts. You'll also notice on the Y-axis they've got 10mm linear rods supporting the print bed, whereas on models like the KE there are only 8mm rods. Coming off the back of the print bed, you'll also notice a very robust looking heated bed cable and strain relief, which is nice to see. And if you take a peek under the print bed, you'll find 4 strain gauge sensors at all 4 corners like the K1 series, and unlike the KE, which uses 1 strain gauge sensor and then the CR Touch to do the auto bed leveling. On the back of the print head, you'll find what I like to call the backpack fan, which is essentially an auxiliary part cooling fan. This would be analogous to the giant side cooling fan that's found on the K1 series, but the V3 has no enclosure panels to attach a fan like that, so they've put it on the back of the print head, and you can see that it fires from the back towards the front of the machine, and you still have the normal part cooling fan with the 2 outlets on either side of the nozzle. And one final non-functional but fun feature is the backlit Creality logo on the print head. So now that you know what this machine is all about, let's get printing. If you haven't already downloaded Creality Print, this is Creality's latest and greatest slicer. We'll talk about other options a little later, but to get started with the V3, you'll want to head up to the drop-down menu in the top right-hand corner and select Add a New Printer. You'll go to the Ender series, add the Ender 3 V3, and by default it selects the 0.4 nozzle, which is what the printer comes equipped with. I'll use the folder icon on the left-hand side and drop in some 3D models here. I'm just going to reposition them to the center of the print bed, and I like using this nut and bolt test because it's a good dimensional accuracy test, as well as testing some pretty severe overhangs on those threads. Over on the right-hand side, I'm going to select generic PLA as the material, and then we can hop in and edit some of the print settings for the normal 0.25mm layer height. Now, mostly everything I'm going to leave alone, although I am going to increase the wall line count to 3 for some better strength, as well as increasing the infill density to 25%. I'll leave all of these speed settings alone. I'm not going to touch anything in there. Support, this model does not need any support. As for the nozzle temperature and the print bed temperature, For some reason in Creality Print, I noticed that their print profiles for PLA by default usually have the build plate temperature at 45 degrees Celsius, which I find insufficient, so I always increase that to 60 degrees. And for the material that I'm using, I'm going to decrease the nozzle temperature to 220 degrees. And finally, the last setting I'll change is in the build plate adhesion, and I'm going to turn the brim off, as this model has enough surface contact with the print bed that I shouldn't need a brim. I'll save those settings and then I'll press the slice button in the bottom right hand corner of the screen, and we'll see what kind of output the slicer comes up with. And obviously this is not intended to be an exhaustive guide on slicing files, but rather just showing you how quickly you can get up and running with Creality Print and how easy it is to get the G-code output. In the print preview on the right hand side, you can use the slider to check out your model cross section layer by layer. And this is a great way to check if your infill is looking dense enough, even count your number of wall layers, and just generally check for any potential issues before sending it off to the printer. On the bottom right hand corner, you got a few options for sending this G-code to the printer. I'm going to be exporting to local and using a USB stick, as I'm battling with some network issues on my workstation. But I've had zero issues in the past sending my files over Wi-Fi to my various other Creality printers like the K1, K1 Max, and even some of the V3 KEs. If you've done everything correctly, the V3 should start laying down some plastic, and this is the actual first print that I filmed on this printer. I did not run any practice takes. The machine had automatically figured out the nozzle offset, and the first layer went down perfect. It seems like desktop 3D printing is finally getting to a place where shortly after unboxing and assembling your machine, you can get to printing right away with minimal hassle. And in fact, there was absolutely zero hassle with this machine here. And as the first print was going down, I was quite impressed with the quality of the parts before I even took them off the print bed. And once I had the chance to finally remove them after the build plate cooled down, I thought they looked fantastic, considering I spent almost no time at all playing with any of the settings inside of the slicer. You guys saw that I maybe made a few small changes, but nothing significant. So at least the print profiles in Creality Print are also great for beginners. They're pretty much ready to use out of the box. All of the exterior perimeters on these parts look great. Very, very minimal signs of any sort of ghosting or artifacting that could be related to vibration. The Z seam could be a little tighter. Perhaps in the future I'll play with the new scarf joint feature on some of the other slicers, but otherwise the steep overhangs on the threads came out looking amazing. So the part cooling is working great, and the male and female threads fit together with absolutely no resistance when turning them, just as intended. Now that we've got the first print under our belt, we'll look at various other prints here with some unique features so we can check out the results. And one other thing I want to mention is that all of these video clips of the printer running have not been sped up, so what you see is what you get. Now I printed this part here because it's got a lot of flat walls, and I wanted to see how those would look. It was sliced with Creality Print, and the first thing I noticed before even looking at the walls is the presence of some very fine stringing, which I'll have to look at some of my material settings like the nozzle temperature and see if I can get rid of that. It's pretty easy to clean up with a heat gun, but otherwise the first layer was absolutely flawless. The walls are also looking very smooth. No signs of any significant ghosting or ringing, which you would normally see around those holes on a flat surface. And with regular black PLA under this kind of lighting, if it was a problem, you'd definitely see it. The vertical walls also looked really consistent, which perhaps can be attributed to the belted Z axis, but later on we'll do some different tests with some even taller models. The next part we'll look at here is the top half of one of my snap latch cases, and the reason that I printed this one is that it's got the logo on the bottom surface, as well as having a bunch of different transitions from straight walls to some of those ribs and ridges on the case, which again, under most circumstances, should result in some ghosting or ringing if the input shaping is not working correctly. I was pleased to see this wasn't the case, and I was left with some very nice looking external perimeters with, again, no ghosting or ringing artifacts. The first layer went down perfect. The logo turned out really nice, and it's a very shallow logo, so sometimes you see some drooping on the next solid layer, but the part cooling took care of that. Beyond that, there's just some very fine stringing, which I'll remove with a heat gun. But the one small blemish that I can see here is on this top solid surface layer, and it looks like a little bit of pillowing, so perhaps I could add an extra top surface layer or even increase the infill density and get rid of that. Otherwise, it's another really nice looking part, and I actually like the fact that on the V3 they have the textured build plate that comes standard, so it imprints that texture on the first layer of the model. So now I'm back in Creality Print and I want to do a spiral vase mode print. So in the print settings, you'll head down to special modes and activate the spiralize outer contour. And when working in spiral vase mode, one thing you may want to consider is changing the minimum layer time. Decreasing this number will vastly increase the speed of the print, but you have to be careful because your model will now only be one wall thick. And if you're laying down one hot layer on top of the next, very quickly you're going to be adding a lot of heat in one area, and if you don't have proper part cooling, this is going to lead to warping. And so I reduced the minimum layer time to 2 seconds, and I figured this would be a good test of the part cooling, and since this model is taller, also a nice test on the Core XZ system of the stability of the Z axis. I also switched up the filament color, and during the removal of this print, you can see that the bottom layers separated where there was a very severe overhang. And this is not the fault of the printer, this is pretty normal when you have a very severe overhang with a single outer wall. Essentially you're stacking one layer on top of the next with very minimal contact between those two layers. But otherwise the rest of the print looked absolutely incredible, but I wanted a model that wouldn't crack when I removed it from the build plate, so I went with this sawtooth blade style vase mode print, and this one here will take an even closer look and see how nice this one turned out. As with all of the other prints, the first layer was absolutely perfect, but I want to focus on these outer walls, and you can barely see these layer lines. Now this filament color may be a little more forgiving than a gloss black, but the result is still exceptional. I'd definitely be inclined to contribute the smoothness of these outer walls on a print this tall with the new Core XZ system. And as I squeeze this print, you can also see that there's no issues with the layer adhesion when there are no steep overhangs. And with that very impressive result, I also wanted to test a tall vase mode square tower, and this uses almost all of the available Z height on this printer. I also twisted this profile and then printed another one rotated at 45 degrees to see if I could notice any differences in the quality of the walls when they're oriented in the X axis, the Y axis, if they're twisted up, or again if they're printed at 45 degrees. In the not twisted square profiles, the extrusion and layer consistency on those flat walls and even around the corners was exceptional. I was very happy with how those turned out. Now on the twisted profile, I did experience something a little strange. In the top half of the model, you can see some warping along these sharp edges. And because these edges are spiralized and that warping wasn't down the entire edge of the model, I'm leaning towards this being part cooling related since the part cooling ducts are directional. I still had the minimum layer time set to 2 seconds, and so if you're experiencing this issue, you may want to increase that setting in the slicer. Despite most of this printer working flawlessly for me, the one piece that I did find to be a little awkward was this anti-tangle bracket thing. It works okay for some spool sizes, but it's not quite as a universal fit as I'd hoped it would be. Occasionally the filament can still make its way past the edges of this spring-loaded bar and does still get tangled. Plus, when the spool is moving, it tends to grind across the edges of this bracket. I still had a handful of occasions where the filament would still get tangled and it would lead to a failed print. To solve this issue, I designed a freestanding top mount spool stand, and this is a universal spool stand, so it fits all of the Ender 3 models and even the K1 and K1 Max series. It features a tool holder in the base that can handle all of the tools that you'll find in the generic Ender 3 accessory kits, and your side cutters can be conveniently stored on the bracket above that, very close to the spool, so they're never out of reach when you're about to change filament. I've yet to find a spool that does not fit the spool holder at the top of the mount, and the friction on the spool holder can actually be adjusted. The filament runout detection sensor gets relocated to the top of the frame, and it's mounted on a ball joint, so the filament is always getting fed into the extruder at the proper angle. Relocating the filament sensor is very easy. There are 2 printed brackets plus 1 screw for this setup. On the main bracket, there's a recessed pocket where the ball joint mount will fit inside, and you'll see that the holes in the 2 pieces will line up. Then you can insert the M3x10 thread forming screw into the back, and with that screw tightened down, the 2 pieces will be attached together and the ball mount will be complete. Next, we'll be attaching the runout detection sensor to this mount, but first, of course, we have to remove it from the machine, and to do that, first we can remove the wire harness from the side of the sensor, and it just simply unplugs. And then there are 2 screws on the front. These are M3 flathead screws. Remove those and the runout sensor simply pops right off. Next, you'll want to pull the runout sensor cable out of the protective wire jacket that goes up to the print head, and we're going to be rerouting this cable in a moment. But first, we can remove the reverse Bowden tube from the print head and detach it from the print head wiring harness. You can also remove the retaining clips from the wire harness since you'll no longer be needing those. Now we can take our filament runout detection sensor and attach it to the ball joint bracket using the included M3x20 thread forming screws. The 2 holes in the runout detection sensor body will line up with the 2 holes in the ball joint mount, and the thread forming screws will cut their own threads into the plastic and secure the runout sensor in place. And since the ball joint mount can swivel around 360 degrees, there really is no up or down orientation here until you, of course, feed the filament in, and you'll follow the arrow sticker on the front of the runout detection sensor. Now we can install this assembly onto the top of the printer frame using the 2 included M3x10 socket head cap screws. This is easiest to do facing the back of the printer. You'll find in the back of the frame there are 2 unoccupied M3 female threads. The holes in the back of the bracket will line up with those 2 female threads, and again, using the M3x10 socket head cap screws, you can secure the bracket in place, and it will look something like this when you're done. Now we can deal with our runout sensor cable, and we're going to be routing this up the side of the frame. Now, unlike previous Ender 3 models that used V-slot extrusion frame, this is a custom frame. It's completely smooth, and so there's not a whole lot of places here to grab onto. So instead, what we're going to be doing is using these adhesive cable tie clips that are also included in this kit. We'll place a few of them evenly spaced along the side of the frame and 1 up on the top beside the runout detection sensor. And then we can take the included extension cable and plug it into the runout detection sensor. Now this one here is in 2 pieces because as I was creating this video, I didn't have a long enough extension cable. The one that will come in your kit will be a single piece that is long enough to reach the original harness. Using the adhesive cable tie clips and the included cable ties, you can start to route the cable down the side of the printer. Keep the cable ties loose at first until you get everything in the place that you want it, and then you can tighten those up. Although I would recommend to leave the very top one still a little bit on the loose side so the ball joint mount has some room to wiggle around and it's not pulling on the cable. The stand itself can now be placed beside the printer, and the support legs will slide right underneath the Ender 3 V3, and up at the top you can remove the conical retaining nut for the spool, put your new spool on top of the spool holder, and secure the nut down. The filament should be routed up and over the spool and into the top of the runout detection sensor. That small piece of PTFE tube was the original piece from the Ender 3 V3, and then we can take our filament down, insert it into the print head, and now we have a nice direct filament path from the spool down into the top of the extruder. With the print running, you can see the ball joint mount at work. The runout detection sensor is swiveling side to side, maintaining a nice angle for the filament to enter the extruder. I'll have a separate video detailing the assembly of the spool stand coming soon, and you guys can find this spool stand on my website, embracemaking.com. On my website, you'll also find these pattern build plates which fit the Ender 3 V3 as well as all of the other Ender 3 models, and I also have them for the K1 and K1 Max series. These build plates are very popular right now, and the pattern that you see on the plate is imprinted onto the first layer of your print for a really interesting look on that surface. And all of my plates are double-sided, so the other side is a regular gold PEI textured surface. Now back to the printing and slicing. One of the things that I briefly touched on earlier was that with Creality Print, I did notice that on some top surfaces, I ended up with some pillowing. Now it was never that severe and it may have been addressed in the latest updated Creality Print, but I decided to try out OrcaSlicer with the Ender 3 V3, and there wasn't a profile for this printer when I first started using it, because remember, I did get this printer pre-release. But because this printer appears to have what is basically the K1 print head, and all of the axes are on linear rods, I decided to slice the files using the K1 profile. I only made a few minor changes to the profile, things like the number of top shell layers, and I changed in this case the layer height to 0.2 millimeters, but I essentially left all of the speed settings alone, and I decided to just send it to the V3 and see how the parts would turn out. Now, despite some of these similarities to the K1, of course, these two printers do have completely different motion systems, the V3 being a more traditional bed slinger versus the K1's Core XY motion system. I figured there might still be some differences in the quality of the prints. Fortunately, I also own a K1C, so we will be able to do a head-to-head comparison with the exact same sliced files on the exact same USB stick. And hopefully this gives you some sense of the performance difference between the two printers, because of course the K1 and K1 series printers are more expensive than the V3. I should also note that I'll be using the exact same material, so this is going to be pretty much an all things being equal comparison. OrcaSlicer says this model here should take 1 hour and 20 minutes to print, so I'm going to send it off to the V3 first, and the result is a successful print at 1 hour and 19 minutes. The same file on the same USB stick was completed on the K1C in 1 hour and 22 minutes for a difference of 3 minutes. Now I believe that difference has to do with the initial calibration, but either way you can see that the V3 did not take any additional time, and this is the result here using the K1 settings on the Ender 3 V3. Overall, the part looks really good. There are some what appears to be vibration related artifacts along the one wall. So that's the V3 part in my left hand, the K1C part is in my right hand, and you can see those artifacts are not present on the K1C. At the bottom, the first layers are indistinguishable from one another, and along the back, you can see again a little bit of the vibration related artifacts in my left hand, so that's the V3 model, whereas on the K1C, they don't seem present at all. But otherwise on the curved sides, they look completely identical to me, and both of these parts still have some of that very, very fine stringing or wisping, which has been exclusive to this brand of black PLA. After that, I decided to do a few more test prints with the V3 versus the K1C. This model here was completed in 1 hour and 27 minutes on the V3, and the same model with the same G-code, same USB stick was done on the K1C in 1 hour and 29 minutes. So again, just a difference of a few minutes here. And these parts have quite a few more straight and flat faces. To remain consistent with the last comparison, in my left hand, I'll hold the part that comes off of the Ender 3 V3, and in my right hand, the K1C. And in this case, on these flat faces, there's barely a difference between the two parts at all. And it doesn't seem to matter which of the faces we're looking at, whether the face was aligned with the X-axis or the Y-axis, I really can't see a difference between these two parts. So I'd say that's a pretty big win for the Ender 3 V3, considering the price difference between these two printers. And on the second part of this build, it's more of the same. If somebody mixed up these two parts and handed them to me and asked me which of the two printers they came off of, honestly, I'd be absolutely guessing, as I really can't see a difference between these two. Even on the 45-degree overhang, the K1C does have the advantage of the bigger auxiliary part cooling fan, but there's really no difference here other than that small blemish that I was trying to wipe away, but I think that was something that just happened by chance and it was on the K1C anyways. Now, after running those tests, I was very confident using the K1 profile on the Ender 3 V3 going forward for all of my prints, including some of these more challenging prints like this very large hose adapter here. This part has a lot of severe overhangs, so the backpack fan on the printhead did a nice job of tackling those. I also added a brim to this part because of the small amount of first layer contact area with the print bed for such a large piece. But both the brim and the support material broke away from the part very clean and left minimal marks. Now I did see on the side of this part a few strange lines on the one side, but the rest of the part looked pretty clean. I continued to have some of the fine stringing and wisping that we've seen now on a lot of these black PLA parts. I noticed that I wasn't getting that result with other brands of filament, so again I'm going to have to do some fine tuning for this black PLA. For example, here is one final print using some dual colored silk filament, and this was about a 5.5 hour print on this machine, and you'll see that there was no stringing and the result was extremely clean. Under the arms of this Deadpool bust, there was some very severe overhangs. That was probably the only part of this entire print that turned out a little bit rough. I decided to print it without supports to see how it would turn out in those areas, and there was this spot under his chin that was also a severe overhang, and that came out even cleaner looking than under his arms. Usually this kind of filament is not very forgiving when it comes to artifacts and blemishes, but overall I think this part turned out looking very respectable.
So that covers my experience with this machine so far, and I've been putting it to constant use in my print farm. All the parts have been coming off looking very nice and, more importantly, dimensionally accurate. I haven't had to compensate for any strange or peculiar issues with this V3. The first layers on this machine always look amazing, and I was able to clean up that top solid layer using OrcaSlicer. And again, I'm printing with the K1 slicer profile in OrcaSlicer, so I'm hitting K1C speeds at about 90% of the quality. I've had zero mechanical issues with this printer. Everything seemed to come from the factory in really good condition. If you guys watched my KE video, you would have seen that I did have a few quality control issues with that machine out of the box. They were pretty easy to fix, but at the end of the day, they were still there. This machine seems to be the total opposite. Occasionally I check for mechanical issues like nuts and bolts rattling loose, or even play in the bearings on the bed, and I've seen none of that so far. I also want to note that I have not had any issues with the Core XZ motion system. I know this is not the first printer to employ this sort of thing. I believe it can be found on the Voron Switchwire, but it is the first for Creality, and so I half expected that I could find an issue with that after running the printer over so many hours, but nothing has come up so far and it's been very reliable. My only minor complaint on this printer was trying to find the optimal placement for the spool, and I showed you guys earlier in the video my spool stand solution, which you can find on my website, embracemaking.com. The anti-tangle bracket thing that came with this printer was a good idea in theory, but I did find that it didn't fit all of the spools that I had, and perhaps this is something Creality can revisit in the future. So overall, this has been a really great machine for me, and in terms of the Ender 3 lineup, I would choose this over the KE if you can justify the extra expense. I also have a K1C, which I'm going to be doing a video on, so if you guys are interested in that, be sure to hit the subscribe button down below. But this thing versus the K1C, I would also probably pick this thing if I'm just sticking to PLA and I'm not using any materials that require the enclosure that the K1C has, because of course this is much cheaper and you can save yourselves a few $100s. And one of the last things I want to talk about before ending this video is that the odd time I do get a comment in the comment section down below saying it's pretty easy to give a printer a good review when you get the machine for free. And while that is true, I always try and be as fair and balanced as possible with these videos, and I try and be as thorough as possible as well, and I report things exactly how I experience them. Now, fortunately for me, I haven't yet had a terrible experience with any printer or any brand just yet, but I'm sure that day will come and I will have to make that awkward video to address it. I'm currently working on building out my print farm, and oftentimes I buy the exact same machines that I've given a positive review if I think they're good value. For example, I just bought 4 of these Ender 3 V3s during the Creality 10th anniversary sale, and Creality did not send those machines to me for free. I bought them with my own money, and I certainly wouldn't be buying 4 of these machines for my business purposes to rely on them if I didn't think they were actually any good. So I hope that clears some things up and provides you guys with some confidence in these videos that I make about these printers. If you guys appreciate this very thorough content, consider subscribing to my channel and visiting my website embracemaking.com for upgrades and accessories. Your support is always appreciated.